Thank y'all. I'm very impressed that this many people would come out when the weather's this bad, so that's very flattering. Until recently, it was my job to make assignments for these speaking engagements for 5 states, including Indiana. I hated the job, frankly, because it was all clerical and that's no fun to me. When I got this request, I should have typically given it to somebody in Evansville or somewhere nearby to handle. But I decided I wanted this one because A, I've always wanted to come here, and the reason why, besides just the usual thing, it sounded like such a cool little town, is that my mom says that my great-great-grandfather, a great-great-grandfather on her side, was one of the people who founded this community. And I've always wanted to come and see if that's true. It may not be true, but tomorrow and Saturday I hope to come back. I will come back here, and I hope to find out if that's not true or if it is true. As somebody who's always trying to make the world a better place, I've already had a few people say, when I told them what my research project was going to be, they said something to the effect of, well, that figures, that I would have somebody involved in a place like this. At any rate, I have been an activist now for 42 years, an environmental activist, and then an engineer for 32 years, and an educator for about 22 years. I've dealt with all kinds of environmental problems, literally since I was a teenager. Nothing ever really daunted me until I got to this problem. And this is the one where I go, oh, expletive deleted. This is very serious stuff. It's the only time where I really worry. I have so much material on this computer. We could do this 5 nights in a row and I still would probably have more material. So what I have to do as an educator is choose what material I use for which audience. So you'll see it. But I want to encourage you that if there's a question you have about some other aspect of all this, I want you to feel free to ask it, because if I don't know it off the top of my head, I probably will know it off the top of my head, but I might have some good illustrations as well. I think it's really important as an educator that we not only talk about problems, but we talk about solutions. The solutions, thankfully, is as diverse and covers so much more territory, just like the problem. So I'm going to get through the problem, but then I want to really focus on the solutions because it's depressing if I don't. This is my truth in advertising slide. I hope that you understand the basics of climate science and the climate change problem. I hope that you feel alarmed, maybe not as passionately as me, but I hope you feel like this warrants your attention and your response. And I hope that you will do some things to reduce your contribution to the problem. And that is good enough because other people will see you do it and they might be likely to emulate you. But if you wanted to do more, telling your neighbors and things about it, I hope to equip you to do that too. This is the most often printed photograph in photographic history, which is about 100 years old now. We've been commonly taking photographs. I think there's a reason for it. This is an awe-inspiring. Young people use the word awesome all the time. I'm too old for that, but that picture is awesome, I think. It's one of the things that motivates me to travel this far and come to see you guys. So first we're going to talk about the science, climate science. Just want you to know I do have a sense of humor, and it's okay to laugh. This is what there are deniers out there, let's face it. The deniers would have you to believe that people like me are this flaky. So I thought, what the heck, I'll put it up and we can laugh. I've seen this in 2 other languages. It's made its way around the globe.
That's cute.
This I do not expect you to read. I want you to see it. It is basically the scientific method as it's used for things like evaluating what's happening with the climate. What I really want you to notice is that it's methodical. It is iterative, it's dispassionate and transparent. In science, we don't just say, this is what I think. We have to tell everybody who reads the juried journal where we got our data, how we manipulated the data. That's an inflammatory word. To me, manipulate means you put it into a mathematical equation, but deniers think that means you're playing some trick. But you have to say, what formula did you use? You have to put your design assumptions in, and you have to show how did you test this idea, and you put it to a jury, and if a jury of your peers think that it's coherent and good enough, it gets published with the full expectation that all of your peers are going to take a shot at it and go, well, I think you made a wrong assumption here, or I think you used the wrong factor in the equation. But the point being is that this stuff gets duked out in front of everybody, sometimes for years, until we reach the conclusion. The reason we can live on the earth is that the sun sends light to us. It penetrates our atmosphere, and some of it goes out and some of it stays. And that's how come we can live here. If all of it went out, we would freeze. If all of it stayed, we would be dead. We'd be a desert in short order, and we wouldn't have ever gotten this far. Nobody argues about this. How many of you had a lemonade stand when you were a kid? And how many of you reported to your friends, if not your parents, that you made money? Right. And how many of you did your parents charge you for the sugar and the lemons? And how many of you did your parents charge you for the paintbrush you trashed making the sign? Exactly. My point is this. We in the first world feel pretty good about how we have become a very developed and prosperous nation. And we tend not to think about the fact that we have used millennia of fossil fuel to get here, and it's not being replenished at the rate we're using it. And we're kind of deluding ourselves like little kids with their lemonade stands. This was just a nice way to try to depict it. Why do we have problems? Our lifestyle involves burning fossil fuels. Fossil fuels make what we call greenhouse gases. When I talk about pollution, everybody thinks about industry. Everybody thinks about power plants, maybe. People don't like to think about themselves. You know, almost probably everybody here has an automobile. And in our society, you are structurally dependent on private transportation and cheap oil. And I always tell my audiences, if you don't believe me, you're invited to leave your keys here. And in a couple of days, we can talk. But nobody ever lasts that long because it's true. I mean, we're dependent on this. And so we've got to think of this as our problem too, and not only somebody else's problem. Most of us now live in suburban sprawl or areas where it'd be totally impractical to try to put a bus through this. You guys are networked. You know, you live on a grid pattern, most of you. And so if you wanted to have public transportation, you could. But the cool thing about a small town is most of you can walk to most of the things you need to do. Now, I've only been here for a couple of hours. I haven't noticed a grocery store. Do you have to drive to the grocery? That's a deal breaker for a lot of folks. And I probably don't need to tell you, but the fastest growing demographic group in this country is the octogenarians. As we get older, not all of us need to be behind the wheel. We need to have places where people can get their needs like groceries without getting behind the wheel. But we also, of course, can't forget we have kids who are too young to drive, and we have people who are too disabled to drive, and we have people who are too addicted to substances to be having a driver's permit, or license rather, and we also have people who are just too low income to have private transportation. So one of the things I harp on is we need to have walkable communities, we need to have mixed zoning so that people could have a little grocery store nearby, and that's one of the cool things about this town is you're already there. You never left that way, you still do things that right way, and that's great. You have sidewalks, and I haven't seen a single vehicle parked on top of the sidewalk like I do in so many cities. And then, as a side note, we have now what we call ex-urban development, where, you know, your kids probably don't even have anybody else to play with because they're all doing activities, being driven around to some activity. Okay, so as we do these things, I don't know what this means. Okay, this is the various kinds of greenhouse gases. The font is supposed to represent roughly the volume. So we have much more carbon dioxide than we have methane, which we have much more than ozone, and we have much more of that than nitrous oxides, and then these little bitty things go out in small quantities. But the catch is they're inverse for who heats up the earth the most. These, pound for pound, way heat the earth more than does this one, then does that one, then does that one, then does that one. You always hear people talk about carbon dioxide or CO2. It's because we mathematically convert these greenhouse gases to be the equivalent of that one just to make it simple. So anytime you hear me talk about CO2, I'm usually talking about CO2e for equivalent, just to keep it simple. These are kind of like that's like a disclaimer, so y'all, I don't want anybody to think I'm trying to gloss over stuff. Okay, So we burn all those fossil fuels, we put those greenhouse gases into the atmosphere, and the problem is we then thicken that atmosphere. That's what those greenhouse gases do, and then we trap more sun. I got ahead of myself there, and it won't let me go backwards, but we're trapping more of that heat around the globe than we used to, and that's why we're heating up. And again, I don't think, well, there's probably a few denialists that would argue that that's not true, but most people accept that that's just basic science. Now, what I want to show you, another way to look at this is that here is the Earth, and there is Venus, which is closer to the sun, and the average temperature for us is 59 degrees Fahrenheit, and the average temperature for Venus is 855 degrees F. And you might say, well, yeah, Cunningham, but it's closer to the sun, so of course it's warmer, until we bring up little bitty Mercury, which is even closer, and its average temperature is 333 degrees, and the explanation is the relative thickness of the atmospheres are really the bigger factor as to how warm the planet is. Okay. This is actual temperatures taken roughly since Civil War on the surface of the Earth and the sea. And you can see, anybody here a math major? Anybody here not capable of seeing these numbers are growing? Of course you can. What would be wrong with drawing a conclusion based upon this amount of data? Can we say, okay, climate change is real by looking at this data? Would that be fair? Why not?
Well, because there have been shifts, climatic shifts before history, before people started recording temperatures.
Totally. That would be like me going home and saying to my friends, the women in New Harmony all wear yellow shirts. I'm looking at this one little data point, and there's this whole community of 700 and some odd people. That would be bogus. That would be an unscientific conclusion because my data is not representative. That's the bad news. Here's the good news. You know that if we chop down a tree, we can count the rings, and we can tell how old the tree is. You might even know that if it's a skinny ring, it means it was a drought year, and if it was a wide ring, it meant we had a lot of rain and it was good growth year. Well, we have a similar situation for glaciers. Glaciers, every year, they have so much snow and ice that fall down, but then the next year squishes that layer, and the next layer squishes that layer, and over time, those layers get more and more compacted. The same technology that we use to drill down to make a deep oil well, we can now use. These blades are really sharp. I almost cut myself on one earlier this year because I wasn't realizing what I was doing. They are really sharper than I ever imagined. We now drill down into the glacier and we pull out ice cores of glaciers. We take them to the laboratory and we use gas chromatography, and we analyze to find out what's embedded in that ice from way far away, back 800,000 years on this plot. We've actually gotten a little bit further, but this is my plot. So this shows you the temperature, this shows you the CO2, and this is CO2, this is not CO2 equivalent, and then this shows you the temperature that's all been computed based upon those ice cores. Now, nobody here is a math major, but you can all see those curves pretty much mimic each other.